Hi, and welcome back to this AI-900 Microsoft Azure AI Fundamentals course. In the previous lessons, we looked at AI workloads and responsible AI principles. In this lesson, we focus on something that appears often in the AI-900 exam: common machine learning types and how to recognize them in business scenarios. You will learn how to distinguish supervised versus unsupervised learning at a high level, recognize regression, classification, and clustering problems, understand where deep learning usually fits, and apply a simple exam strategy to identify the correct ML type from a short scenario. If this lesson helps you in your preparation, please like this video and subscribe to the channel so you don't miss the next lessons. Supervised versus unsupervised learning, high level. Let's start with two important categories of machine learning: supervised and unsupervised learning. In supervised learning, the training data comes with labels. Each example includes both inputs and the correct output. The model learns to predict the label from the inputs. Examples of supervised learning: predicting a house price based on size, location, and other features, classifying an email as spam or not spam, predicting whether a customer will churn or stay. In unsupervised learning, the training data does not include labels. The model tries to discover structure or patterns in the data. There is no correct output provided for each example. Examples of unsupervised learning: grouping customers into segments based on behavior, finding clusters in high-dimensional data, detecting natural groupings in documents or images. For the AI-900 exam, you do not need to implement these algorithms, but you must recognize when a scenario describes supervised or unsupervised learning in simple terms. Regression, predicting numeric values. Now let's look at specific ML types, starting with regression. Regression is used when the goal is to predict a numeric or continuous value. Common examples: predicting the price of a house, forecasting monthly sales for a product, estimating the energy consumption of a building, predicting the time to failure of a machine. Typical exam hints for regression: predict a value, estimate a continuous quantity, forecast future numbers based on historical data. Output is a real number that can vary over a range. If the output is a number, not a category, and that number can take many possible values on a scale, you are most likely dealing with a regression problem. Regression is a form of supervised learning, because the training data includes the target value to predict. Classification, predicting categories or labels. Next, classification. Classification is used when the goal is to assign a category or label to each example. There are two main kinds of classification you should remember: binary classification, two possible classes; multi-class classification, more than two classes. Examples of binary classification: spam versus not spam, fraudulent transaction versus normal transaction, customer will churn versus will not churn. Examples of multi-class classification: sentiment, positive, neutral, or negative, risk levels, low, medium, high, product type, category A, B, C, and so on. Typical exam hints for classification: yes or no decision, true or false outcome, assign one of several categories, label each example as belonging to a class. If the output is a discrete label rather than a number on a scale, the ML type is classification. Classification is also a form of supervised learning, because each training example comes with the correct label. Clustering, discovering groups without labels. The next ML type is clustering, which is a classic example of unsupervised learning. In clustering, we do not have labels in the data. Instead, we want the algorithm to discover natural groups or clusters based on similarity. Examples: segmenting customers into groups based on purchase history and behavior, grouping products that are frequently bought together, grouping documents by topic when no labels are available. Typical exam hints for clustering: we do not have labeled data. We want to discover segments or natural groups. We want to group similar customers together. We want to explore the data and find structure. In this case, there is no predefined correct class. The model organizes data into clusters so that items within a cluster are similar, and items in different clusters are less similar. When you see no labels and discover groups, you should think clustering and unsupervised learning. Deep learning, neural networks for complex data. Now let's talk about deep learning. Deep learning is a subset of machine learning that uses neural networks with many layers. It is especially powerful for complex, high-dimensional data, such as images and video, audio and speech, natural language text, and many generative AI scenarios. Typical uses of deep learning: image recognition and object detection, speech recognition and voice assistance, machine translation and advanced NLP. Large language models used in generative AI, such as Azure OpenAI models. In the AI-900 exam, you do not need to design neural networks. But you should recognize when a solution is likely to rely on deep learning, especially when you must process large volumes of images or videos. You need accurate speech recognition or translation, or you are using large language models to generate text or answers. So, when you see complex vision, speech, or generative AI applications at scale, you can think this is a deep learning style scenario. Practice mapping scenarios to ML types. Let's practice mapping a few scenarios to machine learning types. Scenario 1. A company wants to predict how many units of a product will be sold next month, based on past sales, marketing spend, and seasonality. Here the goal is to predict a numeric value, the number of units sold. This is a regression problem. Scenario 2. An online service wants to classify incoming support tickets as billing, technical issue, or feedback. The output is one of several categories. This is a multi-class classification problem. Scenario 3. A telecom provider wants to identify customers who are likely to cancel their subscription within the next 3 months. Each customer is labeled as either will churn or will not churn. This is a binary classification problem. Scenario 4. A retailer wants to group customers into segments with similar purchasing behavior, but there are no existing labels for customer groups. There are no labels. The goal is to find natural clusters. This is a clustering problem and an example of unsupervised learning. Scenario 5. A team wants to build an image recognition system that can classify thousands of product images into categories with high accuracy. This scenario is likely to rely on deep learning techniques for image recognition. Even though at a high level, it is still a classification task. In the exam, you will often see scenarios like these, and your job is to quickly identify the best ML type for each one. Recap and exam strategy. Let's recap what you learned in this lesson. You saw that supervised learning uses labeled data to learn a mapping from inputs to a target output. Unsupervised learning works with unlabeled data and finds patterns or structure in it. More specifically, regression predicts a numeric or continuous value. Classification predicts a category or label, binary or multiclass. Clustering discovers groups in unlabeled data. Deep learning uses neural networks with many layers, and is powerful for images, speech, text, and generative AI. For the AI-900 exam, a good strategy is to ask 3 quick questions for each scenario. Is the output a number or a category? Do we already have labels, or do we want to discover structure? Is the problem dealing with complex data like images, audio, or large language models? Your answers to these questions will guide you toward regression, classification, clustering, or deep learning. If this lesson was helpful, please like the video, subscribe to the channel, and continue to the next lessons where we will connect these ML concepts to Azure Machine Learning and other Azure AI services for the AI-900 exam. Thank you for watching.